Humanity is on the verge of a technological transformation unlike any other as we enter the age of artificial intelligence. AI is fast becoming a disruptive technology in our world with implications we are only beginning to understand. Whether this will be good or bad is yet to be seen, but regardless, it can offer a vital piece in the puzzle of understanding the nature of consciousness. Is it possible to build an artificial brain of hardware and software that is truly self-aware and able to comprehend meaning? Or will they only ever follow predetermined patterns? To understand, we need to examine the ideas of great thinkers in this field. Let's first explore the Turing Test, a significant moment in AI history, and Alan Turing himself who developed it. The British mathematician, logician, and computer scientist made significant contributions to history during World War II. Even before the outbreak of war, the German military was encrypting all vital communications using a machine called Enigma, which was originally created by German engineer Arthur Scherbius. This device essentially was like a typewriter that randomized the output of every letter key that the operator pressed, changing it into another. Changing just one setting on the device produced a completely different randomization sequence. This led to there being 103 sextillion possible translations of a message. That's 103 followed by 21 zeros. Although Polish mathematicians had figured out how to break this code before, this was done manually and painstakingly, and they couldn't figure out how to keep up with the daily settings changes. It was during Turing's time at Bletchley Park, England, in early 1940, that he and a team of codebreakers built a machine called the Bomb. This drastically sped up the decryption process of Enigma to less than a day, and used the intercepted messages to learn what the next day's setting would be. The ability to intercept and translate these messages enabled the Allies to know every next move of Nazi Germany and other Axis forces. This is hailed as one of the key reasons the Allies won, shortening the war and saving countless lives. The machine built by Turing would inspire future designs including Colossus, which is regarded as the world's first computer. So that's the origins of it, but Turing's post-war reflections on AI are more relevant today. In his 1950 paper, Computing Machinery and Intelligence, Turing sought to establish whether a machine can display intelligent behavior that is indistinguishable from that of a person. In the paper, he named this concept the imitation game, but is now widely referred to as the Turing Test. The test comprises a human evaluator on a computer terminal having a conversation with both a human and a machine designed to give human-like responses through written text, without being able to see or hear them. The human evaluator knows that one of the two partners is a human and the other is a machine, and they have to try and find out through conversation which is which. The machine is deemed to have passed the test if the evaluator is unable to reliably distinguish between the two. A Turing test can also extend to puzzles or problem solving that typically only a human can solve, using a combination of logical and lateral thinking. The Turing test served as a barometer for AI progress and still does to this day. However, it also sparked discussions regarding AI awareness and its nature. Does the ability to pass the Turing test imply real comprehension or consciousness? This leads us on to American philosopher John Searle's Chinese room argument. He was skeptical of the Turing test and called into question what computers and AI could ever truly understand. Here's his thought experiment. A person is locked inside a room where they are receiving Chinese sentences on slips of paper through a slot in the door. This person does not speak a word of Chinese, but in the room there is an instruction book which tells them how to respond to a Chinese speaker outside of the room. Although it could appear from outside the room that the person understands Chinese, to the person inside the room they are just meaningless symbols. Following the instruction book, they are arranging symbols in accordance with the rules and structure of the language. This is called syntax. This produces correct responses, but it doesn't mean the person understands the meaning of them. According to Searle's theory, an AI system might not actually grasp what it is saying, even if it can pass the Turing test. This is the crucial difference between syntax and semantics. Many AI systems are adept at syntax, analyzing intricate patterns and rules. They have the ability to mimic speech, produce text, and solve mathematical issues. But understanding the semantics, the real meaning and significance of what they process, is a different story. Achieving semantic comprehension in AI involves more than pattern recognition. Similar to the human mind, it requires context awareness, emotional intelligence, and the capacity to derive meaning from a variety of sources. For instance, every English speaker knows the difference between a house and a home. Could a machine fully comprehend this difference? So now you may be wondering if any AI has actually passed the Turing test. There are at least 6 AIs purported to have passed it, starting with a program called Eugene Goostman in 2014. Then other AI systems such as Cleverbot, Lbot, and UltraHAL. Most recently has been allegedly passed by Google's Lambda and ChatGPT, With all of these, they are merely mimicking how a human would speak, well enough to convince a panel of judges. It doesn't even need to be a whole panel, just a third of the panel, that they are interacting with a human via a text-based chat. These programs are just utilizing syntactic structures. There's still no evidence that they understand semantics. Perhaps the Turing test needs updating to ensure semantic comprehension, although this would be something that's very hard to prove. For technology has advanced significantly in recent years, the attempt to give robots full semantic understanding is still underway, and the path towards conscious AI is an interesting one. The ethical and philosophical ramifications must be kept in mind as we push the limits of technology. And I'll leave you with these questions. Do we even want machines that are conscious? And if machines do eventually become sentient and capable of experiencing feelings, should they deserve the same rights as people? Thanks for watching. This is Nexum, a brand new channel I've started to be able to explore the fascinating concept of consciousness through fields such as AI, neuroscience, quantum physics, psychedelics, and philosophy. If you enjoyed the video, please support me by subscribing so I can grow and develop, and I can continue to make more videos like this.